All right, let's dive in. We're about to crack a code that's hidden inside the numbers you see and use every single day. It's the code that separates the normal, predictable numbers from the ones that are, well, a little bit wild and mysterious. Let's get into it.
So here's the big question we're going to tackle. When you see a price on a tag, or the number pi in a formula, or a fraction in a recipe, what's actually separating them? I mean, they all look like numbers, right? But as you're about to see, they actually belong to completely different worlds.
On one side, you've got these tidy, exact, predictable numbers. A price like $4.99, a half cup of flour. These numbers are finite. They stop. We can measure them easily. But then you've got these wild ones, like pi and the square root of 2, whose decimals just seem to go on forever, into infinity. Now, the secret to telling these two types of numbers apart, it's actually hiding in plain sight. It is all about their decimal patterns. So let's go ahead and put on our detective hats because we're about to look for some clues. Okay, here's our first piece of evidence, the number 0.25. Go ahead, take a close look. What do you notice about it? What kind of pattern do you see? Or maybe a better question is, what do you notice about how it ends? Yep, if you were thinking, well, it just stops, you are exactly right. This is what we call a terminating decimal. You can think of it as the full stop number. It runs for a couple of digits and then it's done. Finished. Case closed. All right, detective, let's look at our next piece of evidence. 0.33333. And you see those little dots? That tells us it just keeps on going forever. So this one clearly doesn't just stop. So what's its deal? What's the pattern here?
We like to call this one our broken record number. It has a pattern that gets stuck in a loop forever. In this case, that number 3 is just on repeat. So, even though it's infinite, it's still predictable. We always know what's coming next.
And now for our last and probably most famous piece of evidence, the number pi. We all know it starts with 3.14, but it just keeps going and going and going. Okay, look really closely at those digits. Unlike our broken record, is there any kind of predictable loop here? Can you guess for sure what the very next digit is going to be? And the answer is no, you can't. There is no repeating pattern at all. This is our endless adventure number. It goes on forever, but you never ever know what digit is coming next. It's totally infinite and completely unpredictable. So here is the big reveal. These 3 decimal personalities we just found, the full stop, the broken record, and the endless adventure, they are the clues that sort every single number into 2 massive families. So let's check out the official family tree. Every number you can possibly think of is a real number, and that huge family has 2 main branches. The predictable ones, they all belong to the rational family, and those wild, adventurous ones, they belong to the irrational family. And listen, here's a fantastic way to remember this. Rational numbers are ratio-nable. Get it? Ratio-nable. That just means you can write them as a simple fraction, a ratio. Their decimals are the predictable ones we saw. They either stop or they repeat. Irrational numbers, on the other hand, are unratio-nable. You can't write them as a simple fraction, and their decimals are those endless adventures. Okay, so you've got the theory down. You know the decimal personalities, you know the family names. Now it's time for the classification challenge. Let's see how you do sorting some of these tricky numbers. First one up, the square root of 9. Now, I know what a lot of people are thinking. You see that square root sign, and your brain immediately wants to scream irrational. But is that always true? And surprise, it's rational. Why? Because the square root of 9 is exactly 3. And since the number 3 can be written as the fraction 3/1, it is definitely rationable. So remember, not all square roots are irrational, only the ones that don't give you a nice, clean, whole number answer. Okay, here is a classic one we really need to clear up. We've all used 22/7 in school, right, to calculate stuff with circles? So does that mean pi and 22/7 are actually the same number? Not at all. Look at their decimals side by side. It's so clear. Pi is that irrational, endless adventure with no pattern. But look at 22/7, it's a fraction, which makes it rational. And if you look at its decimal, it becomes a broken record that repeats the pattern 142857 over and over forever. It's just a really, really good imposter. Now, this is all pretty fascinating stuff, but what's the point? Like, why does this actually matter in the real world? Well,
It turns out we absolutely need both of these number families to build and understand pretty much everything around us.
This example just nails the difference perfectly. Think about a carpenter building a table. They need rational numbers, precise, finite measurements they can actually mark with a pencil. But then you have an engineer designing a satellite dish. They rely on the concept of an irrational number like pi to get the theory right, even if they end up using a rational approximation for the final build. See? We need both worlds, one for precision and one for theory.
All right, I've got one final challenge for you, and this one will really stretch your brain. If you multiply one of those endless adventure numbers by another endless adventure number, is the answer always going to be another endless adventure?
And here is the mind-blowing answer. Nope. Check this out. You take the square root of 2, a classic irrational number, and you multiply it by itself. And what do you get? You get 2, a perfectly neat, tidy, rational number. Sometimes 2 irrationals can make a rational. And that is just one of the beautiful, amazing surprises hiding in the world of numbers.